Hello friends, how are you? I hope you are doing really good. In the today's video, we will see about cables. The structures cables. From the cable, its application is cable stayed bridge. You can also see that in the background. It is Golden Gate Bridge. Observe how cables are used. So, in the today's video, with practical example, we will see cables. Engineering Fundamentals Guidance by Somayya Sir, Pune, and I am Yugandhara Tadale. Content of the videos are Introduction, Cables, its definition, some basics, problem on cables, then what are pulleys, some notes regarding how to solve the problems on pulley. What is mechanical advantage of pulley block and some problems on pulley. So let's see cables. So this is a cable. It is a string, but we can assume it as a cable. Weight of the cable or self weight of the cable is neglected. And ideally, it is assumed that its elongation is 0. So, this cable, I am pulling the two ends apart. So, it is in tension. Let's check. Yes. Now, I am applying a compressive force. Oops. It is not able to take the compressive force. Now, I am bending it. No, it is not even taking bending. Let's try twisting. Yeah, I twisted it. But still, it is not able to take twisting. Mm, let's apply shear. Shear. Mhm. It is not able to take shear as well. So, this cable takes tension only. So, further to this string that is our cable, I use this key as a weight. I tied this key to this string and now let's see. So here the cable is in tension. Let's check. Yes, the tension in this cable is equal to weight of this key. So it does not depend on the length of the string. The string can be this much long or it can be short like this. But the tension is equal to weight of this key. Further to that weight, I added that weight in the center of the string. So in this way, I added two supports and weight at the center. So I can increase or decrease the span of the cable. Here, the tension is maximum. Let's check. And here, We have seen that tension in the cable is collinear with the cable. If there are pin support at the ends, one vertical and one horizontal component at the cable end will be there, and the resultant will be collinear with the cable. So, in this way, I added two weights and form a catenary. I can increase the weights. So, it does not matter if the weights are here or at the end of the pin. So, can you see? Similarly, the weight is attached for this Golden Gate Bridge. Some basics of cables. All segments of cable are in tension. So here you can see A, B, C, D and E. This is the cable. So all these segments, that is segment AB, segment BC, CD and DE, are in tension. Resultant reaction at cable end, fixed or hinge, is collinear with cable and it is equal to tension in the cable. Ideal cable is assumed to be completely flexible and incapable of elongation. Self-weight of cable is neglected for analysis. Method of joints and method of section both are applicable to cable structures. Cables, for that, summation of moment at any joint is equal to 0 by considering forces on any one side of the joint. For cable structure subjected to vertical loads only, the segment which has maximum inclination with horizontal will have maximum tension. We have already seen that all cables will be found in tension, and with vertical loads only, the horizontal tension component will be same in all cable segments. Unlike the case of a rope passing over a series of pulleys, however, the total tension in the cable will not be same in every cable segment. Sign convention for tension in the cable is shown like this. The arrows are pointing towards each other. This is positive. If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos.